Hi there, this is Kira, and today I'm going to be going through question 1.3 of the November 2021 Mathematics Paper 1 from the DBE curriculum. I will also go over other sequences and series questions from this question paper, so that's question 2 and 3. All right, so in our last session, I said I wanted to briefly explain geometric sequences before finishing off this question. So I've got a basic example for us here. So when we look at the sequence, we can see that there isn't a constant difference between our terms, okay? And I've told you that that this is a geometric sequence. They will tell you in the final exam what kind of sequence you're dealing with. It's very clear here that what I'm doing is multiplying each term by 2. And this factor of 2 that I'm multiplying each term with, we actually call a constant ratio. All right. So when we calculate the constant ratio for a sequence, we calculate it using this formula, Tn over Tn minus 1. So what I mean is that you can construct constant ratios between all the terms. For example, I can calculate T2 over T1. And if I do that, I get 8 over 4, and I get my result of 2, which I know is true. Then if I do T3 over T2, I get 16 over 8, which is also equal to 2. So that is the most important concept about a geometric sequence, that there is this idea of a constant ratio. So with that idea in mind, we are going to attempt question 1.3. Okay. The roots of an equation are x is equal to negative n plus or minus the square root of n squared minus 4mp all over 2m, where m, n, and p are positive real numbers. The numbers n, n, and p in that order form a geometric sequence. Prove that x is a non-real number. Now, with these kinds of problem-solving questions, I like to extract the important information and actually write it down before I get started. So one of the important things here is that m, n, and p are all greater than 0, okay? Another important fact is that n, m, n, and p form a geometric sequence, okay? I've also got to consider the roots. So that brings me back to my my nature of roots stuff that I explained in the previous video. So now I've done a little summary for us here again of the nature of roots. Remember the nature of roots, we need to consider this b squared minus 4ac thing, which is underneath the square root in the quadratic equation. I need to calculate this quantity when the question I'm given is some equation like ax squared plus bx plus c, and I ask you for which value of something do I have no real roots, 2 real but not unequal roots, or 1 root. But in the case of our question, they've actually given us the form of x. So it's a bit different. They haven't given us an equation. They've given us what form the solution will take. And do you see here that there is a square root? Okay. And what is going to make my solution real, or my roots real or non-real or equal, unequal, is all determined by what's in that root. Because since n and m and p are all positive numbers, if I ignore the root, okay, and I think of negative n over 2m, I can only get 1 root, and it will be real because n and m are positive numbers. But what's happening under the root will influence that, because if what's under the root is negative, then I will have the case of no real roots, as I explained in my previous video. And since in the question, they want us to prove that x, the roots, is non-real, another fact, or like the aim of what I need to show, is that the bit underneath the root, n squared minus 4mp, is less than 0. Okay, now the next part is knowing where to start with these problem-solving questions. So you always want to start with the bit that you have like the most information about, or the bit that you can like manipulate the most. And here it's the geometric sequence, because do you agree right now I can't do anything with this n squared minus 4mp less than 0 thing? Okay, so since MNP is a geometric sequence, the first thing that should pop in your mind whenever you see a geometric sequence, you must tell yourself, I must calculate the constant ratio. Okay, and in a problem-solving situation, we're always going to use the idea that this constant ratio is equal. Okay, so I know that I can calculate this constant ratio by calculating Tn over T1, and that has to be equal to T3 over T2. Now, in this question, T2, let me just keep it there. T2 is N, T1 is M, and I set that equal to T3, which is P over T2, which is N. Now I've got an equation, and equations are good because it means I can solve stuff. Okay, so now when I'm dealing with equations, I don't like having things in the denominator, especially, well, I don't like having variables in the denominator. So I'm going to multiply out by m on both sides because this m will cancel with that m. So it'll free the denominator. And what I do to the one side, I must do to the other. I also want to get rid of the n over there. So I must multiply by n on both sides. Now, on the left-hand side, these m's are going to cancel. And I'm going to get n times n, which is n squared. And on the right-hand side, these n's are going to cancel. And I'm going to get that n squared is equal to mp. Okay, so I can't really simplify anymore. Okay, so this is when you go and look at your other facts. Now, my other fact is I have this n squared minus 4mp that I have to show is less than or equal to 0. I don't actually know that it's less than or equal to 0. Remember, this is my aim. But if I look at n squared minus 4mp, and I've now got this equation n squared minus m is equal to mp, I'm starting to think maybe I should substitute something in here into this form. Okay, when we're dealing with problem solving sums, we always want to look for similarity. So I'm going to use different color. Okay, so if I need to show that n squared minus 4mp is less than 0. So let me consider this thing. And looking here, I see that mp is equal to n squared. So in the place of the mp here, I'm going to put n squared. Now I get that n squared minus 4, I get n squared minus 4n squared, which I can simplify. And this is going to be minus 3n squared, okay? Which has to be less than 0 because n, as they told us in the question, n is a positive number, okay? And actually, any number squared is a positive number, whether it's positive or negative. So this here is going to be positive. And then I multiplied by a negative number, which makes it negative. So therefore, I get that n squared minus 4mp is less than 0, and therefore our roots are non-real. Okay, I know these problem-solving questions can be overwhelming, but if you follow my methodology of writing down the facts and dealing with one fact at a time, it will be a lot easier. It's definitely something you should practice. And these questions are always the last question of question 1 in past papers. Okay, or the final maths papers. Okay, now, as promised, I'm going to go over some series and sequence questions. Okay, so this is our question 2. Given the geometric series x plus 90 plus 81, etc. Okay, we've got to calculate the value of x. We've got to show that the sum of the first n terms is given by that quantity. And we've got to calculate the sum to infinity. Now, first thing I really want to explain is the link between series and sequence. Okay, So we are given the series x plus 81 plus 90, I think. Let me have a look. Plus 90 plus 81. Sorry about that. Okay, plus 90 plus 81. Okay, now this is a series because I want to add all the terms together. Okay, so that's given by that. But all the terms in the series actually form their own sequence. So although we want to calculate the sum of it, this x 90, 81 is a standalone geometric sequence. And it actually follows all the rules of a geometric sequence. And this is a very important fact. And a thing that you should keep in mind when attempting these questions. Okay, so the first question is to calculate the value of x. Now, since I know that x 90, 81 is a geometric sequence, I can apply the principles and ideas of geometric sequences to this problem. And as I said last time, the first thing that should always pop into your mind when you're dealing with a geometric sequence is this idea of a constant ratio. And that is what we are going to use to help us solve this problem. We know that the constant ratio must be equal and that I can calculate the ratio T2 over T1, and that must be equal to the ratio of T3 over T2. Okay, so now I've got myself an equation. Okay, so T2 is 90, T1 is x, T3 is 81, and T2 is 90. Okay, so you can multiply up by x and 90 and all that kind of stuff, but first I actually just want to simplify this left-hand side. Okay, and if you put 81 divided by 90 into your calculator, you get 9 over 10 or 0.9. Okay, so 90 over x is equal to 9 over 10. Now, I do not like having this x in the denominator. Okay, so I'm going to multiply up by x to free it from the denominator. What I do to the one side, I have to do to the other. Now, I get that 90 is equal to 9 over 10 times x. Okay, and I want to get x alone, so I'm going to divide both sides by 9 over 10. Okay, you can literally pop in your calculator 90 divided by 9 over 10, and you will get the expression for x. Okay, or what you can think about is that when you do, so I'm saying divide by 9 over 10. Divide by, or 90. Yeah, it's going to look a bit weird if I do it that way. So let me just adapt a little bit. No, ugh, sorry, this thing is driving me nuts. Okay, let me actually delete that. Sorry. Okay. So 90 divided by 9 over 10. And then I remember when I divide by fractions, I need to tip and times. So if I tip it here, I'm going to get 90 times 10 over 9. Oh, sorry, 10 over 9. And then on this side, it's going to be times 10 over 9. Okay. On the right-hand side, we see that the 9 will cross up with the 9 and the 10 will cross up with the 10. So I'll get x alone. Okay. And on the left-hand side, 90 times 10 is going to give me 900. Okay. And then this 90 is over an invisible 1. And 9 times 1 is 9. And if I divide 900 by 9, I'm going to get that x is equal to 100. Okay, but you don't have to do it this way. You can just put it in your calculator. Okay, cool. So that's the first question done. Do you see how important it is to remember that there is a constant ratio between the terms? Okay, now I'm going to move on to question 2.2, which asks, show the sum of the first n terms is given by Sn is equal to 1,000, 1 minus times 1 minus 0.9 to the power of n. Okay, so to find this Sn, the formula is actually on the formula sheet, which you will find at the last page of your paper 1 final exam. And the formula, so these ones over here, the ones Tn, those are to find the general term of a sequence. And the one with an S is to find the sum or the equation of the series. Okay. The first one, these Tn and the first Tn and Sn in this line are for arithmetic sequences, which we're not dealing with now. And these second ones are for geometric sequence. So the first step in this kind of question would to be to identify the formula you need to use. So we need to use the formula Sn is equal to A times r to the power of n minus 1 over r minus 1. Okay, so Sn is equal to A 1 minus r to the power of n over 1 minus r. I just want to check I wrote it down correctly. Yes, I did. Okay. Now, A in all of these equations or formulas refers to the first term of the sequence or series. And R refers to the constant ratio. Okay. So let's go and fill in all the quantities. Okay. So if we go back to the question, we remember that X is the first term of our series, and remember X is now equal to 100. So A is equal to 100, okay? And R, we calculated it as 9 over 10. Okay, so A is 100, R is 9 over 10, okay, to the power of n. I'm just going to show you that R is equal to 9 over 10. In this little bit here, we calculate R as T3 over T2, and remember we got it to be 9 over 10 over there. Okay. So then all over 1 minus R. Now, why have they got it as 1,000? I think that must be it. Oh, because they simplify here. Sorry. Bit of a blonde moment. And I also should have filled in R as 9 over 10. Now, I can't simplify at the top here. I shouldn't simplify because if you look at the question, it's still a number multiplied by the bracket with 1 minus 0.9 to the power of n. So I want to leave that. And the denominator is going to simplify to be 1 over 10. Okay, 1 minus 9 over 10 will give me 1 over 10. Okay, and I can see in the question that they don't have 100 divided by 1 over 10. They have 1,000. So I want to see what 100 divided by 1 over 10 is. So I want to calculate 100 divided by 1 over 10. So I'm going to come over here to my calculator, and 100, why isn't this 100 divided by 1 over 10 gives me an answer of 1,000. So that's great. I was right. My theory was right. Okay, so now I'm going to write this as 1,000 multiplied by, but in the question, they have the 9 over 10 as 0.9. But remember, 9 over 10 is the same as 0.9. And I'll show you in my calculator if you don't believe me. Sorry, why isn't this working? Okay. There we go. So 9 over 10, you see, is equal to 0.9. Okay, so I'm going to write this as 1,000 multiplied by 0.9 to the power n. And that is what they wanted. So that wasn't too bad. We just had to apply the formula to this series. Now, the next question asks us to calculate the sum to infinity of the series. Okay, now, if we look at our formula sheet, it's given by this S infinity thing. That is how we calculate the sum to infinity. Both of these formulas have these restrictions about R. Sometimes they can ask you questions about like, for which values of R will the series not converge? And then you will just have to like solve an inequality like that. But in our case, our R is 0.9. So do you see it meets the restriction, so we can calculate the sum to infinity. So the sum to infinity is given by A over 1 minus R. So all we need to do is just plug in the values and solve. So the sum to infinity is equal to A over 1 minus R. And remember, A is our first term, which is X, which we calculated to be 100. And then R is 0.9 or 9 over 10. Okay. Now I'm going to plug this whole thing into my calculator. And let's see what we get. Sorry, let's just wait for this app to load. Okay, so we have 100 over 1 minus 9 over 10. And we get 1,000. And that is our sum to infinity. And it is as simple as that. Okay, you just need to remember that for calculating things like the general term, the what did this question ask for? How did they phrase it? The sum of the first n terms, we've got to use Tn and Sn, which we can find in our formula sheet. And to calculate the sum to infinity, we can also find that in our formula sheet. And we also just need to remember that A means the first term and R means the constant ratio. And then it's as simple as plugging into the formula. Now we're going to move on to question 3, which is about a quadratic number pattern. Okay. Quadratic number patterns have to be handled in a very specific way. So I'm going to show you the method. Okay. So consider the quadratic number pattern. Negative 145, negative 122, negative 101. Now we need to calculate the value of T4. Okay. It's not that simple with quadratic number patterns because they don't have a constant first difference. They have a constant second difference. And I'm going to show you what I mean now. So whenever I do a quadratic number pattern, I always do this first step. It's very, very important. Okay, so I write out on my paper the number pattern. Then I calculate the first difference between the terms. Okay, now negative 122 minus 145 is equal to 23. You might be thinking, what on earth am I doing? Well, remember, to calculate the first difference, you need to say T2 minus T1, okay? T2 is negative 122. T1 minus T1, which is 145. So you need to type this entire thing into your calculator just like that, with the brackets between the minuses or negatives there. Otherwise, you're going to get an incorrect answer. And then I do exactly the same thing for questions for T3 and T2. So I say minus 101 minus 122, and I get 21. So do you see my first difference is not constant? But if I calculate the second difference between these terms, so I say this difference 2 minus difference 1, I'm going to say 21 minus 23, and I'm going to get negative 2. Okay. And how this pattern works is that the first differences actually form a linear or arithmetic sequence with a constant difference of negative 2 in this case. So to find T4, I must find the value of the next first difference, which I can calculate by adding negative 2 to 21. So that's going to give me a value of 19. So this second difference here must always be constant. Okay. So if I'm going to label this here, second difference, and it's constant. Okay. And then here is our first difference. And this is actually an arithmetic sequence. So I'm just going to call it an A sequence, seq. And then this one at the top is our quadratic sequence. So now to find the fourth term of our quadratic sequence, I must add 19 to this last term. So minus 101 plus 19 is going to give me minus 82. And then for my final answer, I must write that T4. So this is question 3.1. Okay. And I must say that that T4 is equal to minus 82. Let's just go check that that's right. Minus 82. Great. So now, the next question says, show that the general term of the number pattern is Tn is equal to negative n squared plus 26n minus 70. Now, the quadratic number, the quadratic term of the number sequence does not, sorry, I'm not sure what I was saying there. The general term of a quadratic sequence is not on the formula sheets. I'll show you quickly. This is the paper I'm using. And then on the last page is the information sheet. And in the blue block are all our formulas to do with sequences and series. And we've only got a general term for an arithmetic and a general term for a geometric. So we don't have one for the quadratic equation, a quadratic sequence. So what I'm going to tell you now is something you need to memorize. Okay. So the general term of the quadratic sequence is given by a n squared plus bn plus c. So this is all equal to Tn. Okay. Now, I'm going to show you how to get A, B, and C. You need to remember how I get A, B, and C. Okay. First fact I always use is that A plus B plus C must equal the constant first difference. So, sorry, the constant second difference, which is negative 2. Okay, so that's the first equation I set up. The second equation that you set up is that negative sorry, I actually made a bit of a mistake there. So let's start this again. Okay, so you always start with your constant first difference and work backwards. Okay, so that constant first difference is equal to 2a must equal that constant first difference, which in our case is negative 2. So you set up this equation first and you solve for a. You divide both sides by 2 and you get that a is equal to -1. Then you say that 3a plus b must equal the first difference. So this one over here, 23. Do not use this 21 one or this 19 one. Otherwise, you will get a weird answer. Okay? So that has to equal to, was that 21? 23. Okay? So I now know what a is. So I'm going to substitute -1 in the place of a. And now I need to solve for b. So this -1 times 3 is going to give me -3. Now, to get b alone, I must take this over. And when I take it over, it becomes +3. So I get that b is equal to 23 plus 3. So b is equal to 26. And then the final equation that you set up to get c is you say that a plus b plus c is equal to the first term in the quadratic sequence. So this term over here, -145. So I was a little bit confused when I started this question. So always remember that it's important to remember these equations and that you always start with the constant difference, the second difference. Then you move with this 2a is equal to the constant difference equation. Then you move on to the first difference and you say that 3a plus b is equal to the first difference, and then a plus b plus c must equal to the first term of the quadratic sequence. Okay, so I know that a is -1 and that b is 26. And then I'm looking for c. Okay, so -1 plus 26 is going to give me an answer of 25. Okay, now to get c alone, I must take that 25 over. It is going to become -25. So I get that c is equal to -145 minus 25. And if I pop that in my calculator, -145 minus 25, I get that c is equal to 170. I'm not done because I need to substitute all of these quantities into the formula for the general term. So my final answer is that Tn is equal to a, and a is -1. So I'm just going to write -n squared plus bn, and b is 26. So plus 26n plus c, which is -70. Now, good practice after you're done calculating this is sometimes they tell you what the form of the general term should be. So let's go see if we've got the correct form. Yes, we do. So we've done the right thing. Okay. Now, question 3.3. They love asking this question. Between which two terms of the quadratic number pattern will there be a difference of -121? Now, by this they mean a first difference because it's the difference between the terms. Remember I told you that the first differences actually form a linear or arithmetic sequence. So what we need to do is we need to find the general term of this arithmetic sequence and then substitute a -121 and find the n where that happens. Okay, we also have to add an additional trick afterwards, but don't worry, I'll guide you through it. Okay, so I'm going to do the question over here. So it's 3.3. Okay, so we remember, if we look at our formula sheet, the general term of an arithmetic sequence is given by Tn is equal to a plus n minus 1 times d. Okay, so Tn is equal to a plus n minus 1 times d. Okay, I just want to check that I copied that down right. Yes. Okay. Remember, A always refers, so now we need to substitute in stuff. A always refers to the first term of the sequence. And because I'm working with this first difference sequence, my first term is 23, not minus 145. Minus 145 is the first term of my quadratic sequence. I am looking at my first difference sequence, which is an arithmetic sequence. So A is 23. Okay. Then N, I must always leave N. And then I can substitute in my constant difference, which I've already worked out. That's the second difference of the quadratic equation. So it's minus 2. Okay. You always want to simplify your general term. So I'm going to distribute this minus 2 in. So I get 23 minus 2n plus 2. So then I like to write it as minus 2n. And then I've got two constants, 23 plus 2. If I add those together, I get 25. Okay. So that is the general term of my first differences. Okay. Now I want to find the position, the n, where this first difference of negative 121 happens. So I'm going to substitute negative 121 into this general solution, general term, because Tn is the value of the sequence at position n, and then n denotes the position. So here, because I'm given the value at some position n, which I don't know yet, I substitute that in the place of Tn. Okay, now I want to solve for n. So first thing I'm going to do, let me actually change this to blue. It's a bit silly. Okay, first thing I want to do is take this 25 over. It's going to become minus 25. And negative 121 minus 25, you can pop that in your calculator and you will get minus 146. Oh, that doesn't really look like a 6. Okay, now to get n alone, I must divide out by minus 2. And I get that n is equal to 73. Okay. So now I know the position in the first difference where I have this negative 121. But it asked me between which two terms of the quadratic number pattern will there be a difference of 121? So let's have a think here. Let's say I have T1 of my quadratic equation, T2, T3, and T4. Okay. Do you see that the first term of my first differences, which is my arithmetic equations, I'm going to call it D1, D2, D3. Do you see that the first difference is between T1 and T2? So D1 is between T1 and T2. D2 is between T2 and T3, and D3 is between T3 and T4. So do you see for the 73rd difference, it must be between, okay, the first the first term it's between in the quadratic sequence copies the position of the arithmetic sequence. And then the other term it's between, you add 1 to the position. Do you see this pattern? For D2, the first term of the quadratic copies the position, and then we add 1 to find the other. So here, the first difference so they asked us, between which two terms of the quadratic sequence will we have a first difference of negative 121? Do you agree? Because this difference is in the 73rd position, it must be between terms T73 and then I add one T74 in the quadratic sequence. So as my final answer, I will say between the 73rd and the 74th positions. Please learn this because they really, really like asking this question. Okay. And if you forget how which terms in the quadratic sequence the first difference is supposed to be between, just do this little diagram that I've done here and try and figure out the pattern for yourself. Okay. So let's move on to the final question. What value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern will be 1? This is quite a complex question. It has a few parts. So what value must be added to each term in the number pattern? That's the first part. And the second part is this maximum term will be 1. Okay, so I must add some value to each term in the number pattern. So do you agree my new Tn is going to be equal to my old equation, which is negative n squared plus 26n minus 170. But now I must add some value to it. So I'm going to call that value k. Okay. So now I've dealt with the first part, adding some value. I need to figure out what that value is, but I can't figure that out. So I'm going to use, just with what I've got there, I must use the extra bit of information, is that the maximum term in the new number pattern formed will be 1. Now, a very important thing to think about is that quadratic number patterns can actually be drawn as parabolas because they are quadratic equations. Does that make sense? And we know that quadratic or parabolas, which are the graphs of quadratic equations or expressions, they have this kind of form, okay? Or that kind of form. This one we can see has a minimum value because all other values on the graph are larger than that value. And this one has a maximum value. And do you see that the minimum or maximum value of a parabola or a quadratic expression or equation is always at the turning point? Now, we remember from our graph section, I know it does seem wild that they are asking a functions question in the sequences paper, but they actually really, really, really like to draw the comparison between quadratic number patterns and parabolas. Okay, so we remember from our functions question that we can find the x value of the turning point by calculating negative b over 2a. Okay, so this is the position, the n value, where the maximum will happen. Okay, this function will have a maximum value because we've got a negative a value. So we don't need to worry too much about like, oh, what about the minimum? You just need to find the turning point, and that turning point will be a maximum in this case. Okay, so b in our question or in our function here is 26. So I substitute, or let me just leave it like that and do this. So I get minus 26 over 2 times a is minus 1. Okay, so if I simplify this, 26 divided by negative 2, because this will become negative 2, 2 times minus 1 is negative 2. This will be 13. Okay, so at the 13th position, we will have a maximum. Okay, but we want this maximum value or term to be 1. So I know that it's going to happen at the So if I write it out, the 13th position. So I know T13 is where it's going to happen. So I substitute in 13 to my new, oh, I'm actually running out of space, but here. Okay, so actually, let's think about it. The Tn value I want to have is 1. So I'm going to substitute 1 in the place of Tn and 13 in the place of n because I know this happens in the 13th position. So I have to say that 1 is equal to, okay, my formula is minus n squared. So minus times 13 squared plus 26 times n. So plus 26 times 13 minus 170 plus k. So now I have an equation to solve for this k value. The value I must add to the sequence, to every term in the sequence, so that I get a maximum value of 1. Okay, so now I'm going to simplify. 13 squared is 169. So this is minus 169. 26 times 13, I'm going to pop in the calculator. I get 208. Okay, minus 170 plus k. Okay, so now I put minus 69, minus 169 plus 208 minus 170. I pop that in my calculator and I get minus 131 plus k. To get k alone, I take the minus 131 over and it becomes positive 131 plus 1, which is 132. Therefore, I must add 132 to every term in the sequence to get a maximum value of 1. I know that was a bit of a tricky question, but I hope that my tips for problem solving helped you understand this question. In my next video, I will finish off the last sequences and series questions for this paper, which is question 4. I hope you found this video helpful.